All right, so the topic for the video here is going to be all about similar figures. And our essential question there is going to be, what are similar figures? What are the properties of them? And how do we solve problems with them? So last video we left off with our ancient mathematician friend Euclid investigating congruent figures and proving triangles to be congruent and using CP/CTC and all that stuff. And so where we're moving now, it says after investigating the concept of congruent figures, Euclid moved on to similar figures. And so what are similar figures? Well, this says that similar figures are going to be, if two figures are similar, If two figures are similar, then their corresponding angles are congruent. And the ratios of their corresponding sides are equal. Now, a ratio, you can oftentimes just think of a ratio as a fraction, right? Something over something. And so we'll come back and we'll kind of explore what that means here in a second. The other big idea that we need to know for today is going to be scale factor. Scale factor, you've most likely seen this concept before. Scale factor is the common ratio between the corresponding sides of similar figures. And this can be written as a ratio, a fraction, or a percentage. So what are we talking about here? What are these similar figures? If you look at example 1 here, you're going to see two similar triangles. It says triangle ABC is similar, right? That's that symbol there. Triangle ABC is similar to triangle DEF. Complete the proportions and the congruence statements. Determine the scale factor from triangle ABC to triangle DEF. So you can see these similar triangles here, and you can see what they look like, right? They're essentially the same shape, but different sizes of each other. And how those sizes are related is the scale factor. So let's see what we can do here. Before we dive into those questions, let's just recap here the two big things for similar figures. If things are similar, their corresponding angles are congruent, meaning that the angles have the exact same measures. And then those ratios, the ratios of the corresponding sides are equal. So let's think about that first thing first. Corresponding angles are congruent. So like on A here, it says angle A is congruent to what? Well, angle A is over here, and A is the first letter in the similarity statement, which means it should match up to angle D, right? Angle A is congruent to angle D. DFE, the next angle here, DFE, middle letter F, should be congruent to angle C. So F and C. Obviously, we can tell by the 45s there, but that's what it's referring to. And so if we use the three-letter naming method, angle DFE would be the same as angle ACB. And then CBA, middle letter B, should be the same as middle letter E. So angle B and angle E are congruent. And if I use the three letters there, CBA would be congruent to angle FED. Now this next part is the ratios of the sides. So they're saying AB over DE, they're relating side AB here over DE. We can tell that those are corresponding sides there. That would be the same as BC. Well, BC should relate to EF. And that should be equal to something over FD. Well, what side goes with FD? It should be CA. So those would be those ratios that would need to be equal. And let's examine that real fast. AB over DE, that's 4 over 6. BC over EF, that's 6 over 9. And CA over FD, that is 8 over 12. Now take a look at those and try to simplify those, right? 4 over 6 would simplify down to 2 over 3. 6 over 9 would simplify down to 2 over 3. 8 over 12 would simplify down to 2 over 3. So we can tell all of those things simplify down to the same thing. That's what it means to have those corresponding, or the ratios of the corresponding sides to be equal. If you make a ratio out of two corresponding sides, it needs to be the same no matter which set of sides you're looking at for similar figures. Now this last part says scale factor from ABC to DEF. So they're saying, hey, what's the scale factor going from this triangle to that triangle? Now in general, if you're trying to find the scale factor, you should be doing new divided by old. And what I mean by that is a side on the new figure divided by the corresponding side on the old figure. So if I do, like, let's just look at these corresponding sides here, right? The 6 and the 4. The new shape is DEF because we're going from ABC to DEF. So that would be 6 divided by 4. Now simplified, that's 3 over 2. And if you're getting bigger, then the bigger number should be on top. Or we could write that as a percentage, right? 3 divided by 2 is 1.5. 1.5 as a percent would be 150%. Or we could write it as a ratio using a colon. And if we're doing the colon method of writing the ratio, we would do 2 colon 3. Okay, so those are 3 different ways to expect to see scale factor written every now and then. Most of the time you're going to see it as a fraction. Sometimes you might see it as a percent or with the colon method. But that's what it means to be similar. Corresponding angles are congruent, and the ratios of the sides of the corresponding sides are equal. Okay, now those ratios, let's talk a little bit more about that, because that's going to be what allows us to solve problems using these things. Anytime you set 2 ratios equal to each other, that is called a proportion. And it says up top here, proportions can be used to solve problems using similar figures. So a proportion is an equation that sets 2 ratios equal to each other. So let's say we know that the ratio of 2 corresponding sides is 1 over 2. And we know that another set of sides, we don't know what one of them is, but we know the other one is 6. So if I set these 2 ratios equal to each other, 1 over 2 and 8 over x over 6, then the most commonly seen way of solving an equation or solving a proportion is cross-multiplying. And when you cross-multiply, you multiply across the diagonals. So 2 times x is 2x. 1 times 6 is 6. And then we could just divide by 2, and we would know that x is 3. So solving proportions, pretty easy. You just got to cross multiply and then solve. So with that in mind, let's look at example 2 here, and we're going to try setting up our first proportion. This says triangle ABC is similar to triangle DEF. Solve for x and determine the scale factor. Okay, so let's find one of the sides with an x. So side AB. Now what is that going to correspond to on our other triangle? Well, sometimes it can be kind of difficult if things are spun around a little bit, but always refer back to your similarity statement. Side AB should match up or correspond with side DE. So let's just go ahead and make a ratio out of that. So that would be 2x minus 4 over 2x minus 12. And we know that that should be equal to any other ratio that I set up using corresponding sides. So another side that I know over here is this 12. That's side BC. Well, that corresponds to side EF, the last 2 letters there. So I could set up another ratio to set it equal to as 12 over 6. Now, I could have reversed all of those. Like I could have done the 2x minus 12 over 2x minus 4, but I would need to set that equal to 6 over 12 as well. So just be careful, be consistent with the way that you're setting these things up. So I made a ratio with my yellow sides. I made a ratio with the corresponding green sides. Now I just got to cross multiply. So if I cross multiply here, I need to be a little bit more careful than I was in that really basic example, because now I'm going to need to distribute. So when I multiply the 2x minus 4 times the 6, I'm going to write it like this: 6 parentheses 2x minus 4. Just to remind myself I need to distribute. And likewise, 12 parentheses 2x minus 12. So distributing here, 6 times 2x is 12x. 6 times 4 is negative 24. 12 times 2x is 24x. 12 times negative 12 is negative 144. So let's subtract that 12x. 24x minus 12x is 12x. And then if I add the 144 to the other side, negative 24 plus 144 is 120. And then I divide, and I should get 10. Okay, now the other part of this question wanted us to find the scale factor from triangle ABC to triangle DEF. So notice on this one, we're getting smaller, right? So we should expect a scale factor less than 1. Now let's plug that 10 back in and just make sure this looks good. 2 times 10 is 20. Minus 4 is 16 for side AB. And for side DE, 2 times 10 is 20, minus 12 is 8. So let's check these scale factors. Going from ABC to DEF, remember we need to do new over old, so small on top this time because we're getting smaller. So 8 over 12 using those yellow sides. That simplifies down to, or I'm sorry, not 8 over 12, that should be 8 over 16. 8 over 16 would simplify down to 1/2. So I think our scale factor is 1/2, but let's just double check with the green sides as well. New over old there would be 6 over 12, which would also be 1/2. So this looks good to me. I'm going to give myself a check because I did check my work. And then I will say that the scale factor is equal to 1/2, writing that scale factor as a fraction. Okay, so first one done here. Let's check out a similar one here for example 3. We got triangle ABC similar to triangle EDC. Solve for x, determine the scale factor. Okay, so let's find an x here. There's an x on side AC. That's my first and last letters. So that should correspond to first and last letters EC. So let me make a ratio out of that. 2x plus 10 over 40. Using my yellow corresponding sides. And then I got to set that equal to another ratio. I do know side BC here. That's the last two letters. That should correspond to DC, the last two letters over there. So that should be 3x plus 3 is equal to, or I'm sorry, is over 44. And once again, those ratios of the corresponding side should be equal because these things are similar. That's one of the features of similar triangles. Okay, so now let's deploy our cross multiplication. That should be 44 times 2x plus 10 is equal to 40 times 3x plus 3. Let's distribute. That's going to be 88x plus 440 is equal to 120x plus 120. Okay, if I subtract that 88x, I've only got a 440 over here. 120 minus 88 is 32. 32x plus 120. If I subtract the 120, oh, this is going to be nice. We get 320 is equal to 32x. And dividing then would give us 10. So another x being 10. We still want to find the scale factor, so let's plug that back into those two spots and check that out. If x is 10 for side AC, 2 times 10 is 20, plus 10 is 30. So a ratio made out of my yellow sides. Remember, I am going from ABC to DEF on this one. That's what the question says. So new over old, I'm getting bigger on this one. That's 40 over 30, which is 4/3 for my yellow sides. So scale factor seems to be 4 over 3. Let's double check with the green ones just to make sure we're right. If x is 10 for the green ones for side BC, 3 times 10 is 30, plus 3 is 33. So for my green sides, I would do 44 over 33, which both divisible by 11 there does simplify down to 4 over 3. So I'm going to give myself a check. I checked my work. Everything looks good. And then I will say that the scale factor is equal to 4 over 3. Okay. Let's check out example 4 on the top on the inside here. Determine if the figures are similar or not. Okay, so we needed to check if they're similar. And then we want to determine the scale factor and write a similarity statement. Okay. So to check if things are similar or not, at this point in the game, we know that similar figures have congruent angles and they have sides whose corresponding ratios are equal. So let's check those angles first. Angle A and C seem to be congruent to G and E, so that's good. And then angle D and B are congruent to H and F. So I don't really know exactly how these things correspond right now, but I do know that the angles are congruent. So I'll make a note here that we do have congruent angles. So that's one of the things we need to do. And then remember, the other thing was that their sides, the ratio of the corresponding sides needs to be equal. So let's pair up some sides. Let's check the small sides over here with the small sides over here. Now we're trying to go from, it says from EFGH to ABCD. So in this case, we're going this way. So if I do new over old, I would be checking 30 over, 30 over 45, which would be 2/3. And then for my longer sides, we'll pair those up as well. So 63 over 42. That is also, oh no, I'm sorry. I need to do new over old. I switched that. So this should be 42 over 63, which both divisible by 21 is also 2/3. So that seems to work out. So here's what we'll say. We will say that they are similar. We will say that the scale factor is 2/3. And then we will say for a similarity statement, I could say let's do EFGH. EFGH is similar to ABCD. So once again, we knew that they were similar because angles were congruent, and those ratios reduced down to the same thing when I paired them up. The scale factor we found by doing new over old. We were getting smaller, going from EFGH to ABCD, and then we wrote a similarity statement by making sure that the letters were aligned. Now for our last example in the notes here. It says ABC similar to ADE, solve for X and Y, and determine the scale factor as a fraction. Okay, now to get things started here, take a look at this. This one's weird because these triangles are overlapping, and sometimes that can be confusing. We are saying that this big triangle is similar to the small triangle. Okay, so we need to be very careful with how we are setting up these ratios. So to solve for X, let's start with X. We see that X is on side BC, right? Side BC is 9X plus 2. Now BC, the last two letters here, would go with the last two letters here, DE. So that'd be 9X plus 2 over 8. Now, if I want to set that equal to another ratio, I don't want to do it with the y's because I can't solve an equation using x and y's. So let's do the left sides of the triangles because those are some sides with some numbers, okay? So the left side of the triangle, the left side of the yellow triangle, this is weird, but it's not 18, right? I need to use the whole side of the yellow triangle. That's 30. So whole left side of yellow triangle over whole left side of green triangle, which would be 12. And that was me looking at side AB, the first two letters, with the first two letters here, AD. Okay, so that was kind of a tricky one to set up. But doing this now, I've got the x's equal to a ratio just using numbers, so I should be able to solve this. So 12 times 9x plus 2 is equal to 30 times 8, which is 240. 12 times 9x, when I distribute, is 108x. 12 times 2 is 24. It's equal to 240. If I subtract the 24, I get 108x is equal to 216. And then dividing, I should get x is 2. Okay, now let's plug that back in. 9 times 2 is 18 plus 2 is 20. And that seems all right for now. Let's set up another one and solve for y here. Now, for y, okay, this is going to be tricky as well. So let's do, what's the best way of doing this? So the whole side here for the right side, because if we keep that same strategy as doing right side over right side equals left side over left side, this whole thing, 2y plus 2y plus 6, that is 4y plus 6. So here's what I'm going to do. I'm going to do, if I do the same strategy as I did before, so whole right side, 4y plus 6, over right side of the green triangle, which was just 2y. So right side of yellow triangle over right side of green triangle equals left side of yellow triangle over left side of green triangle. Okay, so whole right side over top right side equals whole left side over top left side. And you can see it in the letters there by me doing AC, which would be AC over AE, right? All right, so we got the equation. Let's cross multiply and solve now. So I've got 12 times 4y plus 6 equals 30 times 2y, which is 60y. If I distribute, 12 times 4y is 48y. 12 times 6 is 72. It's equal to 60y. If I subtract the 48y, I'm going to get 12y. And then 72 divided by 12 is 6. Okay, so let's plug that back in now. If I plug that back in, 2 times y for AE, 2 times 6 is 12. And then 2 times y is 12 plus 6 is 18. So it actually ended up being the same as the other side. So 12 times 18 for the whole thing there, I'm sorry, 12 plus 18 for the whole thing is 30. So now the last part here was solve for the scale factor. Now, scale factor it says from ABC to ADE. So that means that we're getting smaller, right? ABC is the big one. So let's do big over small for all three sides here. We got one side that's 30 over 12. 30 over 12. If we simplify that down, that is both divisible by 6. So that's 5 over 2. We have another side that's 30 over 12, the right side, which is also 5 over 2. And then the last side, the bottoms there, that would be 20 over 8, both divisible by 4, which is also 5 over 2. So all of those worked, which means that our scale factor oh, you know what? I forgot there that we're going from ABC to ADE. So if we're doing new over old, I actually need to flip that. That's 2 over 5. Because we're getting smaller, so I need to put the small number on top. Yeah. It still worked as a way of checking, though, to make sure that all those ratios were equal. Okay, so that last one was pretty tricky, huh? Time for you all to try some out. So on your turn page there, you got one kind of like the first one we did where you need to be plugging in the correct values, matching the stuff up the right way. And then you got one that you're going to solve for X and Y on. All right, so give those a shot and then come back to the video when you are ready to check. All right, so checking some stuff out here. So M in O should be congruent to angle ABC. That's this one with this one, so that should be a 52. BAC, if we're checking the right letters there, BAC should be angle NMO. That's this angle with this one. And then angle O, the last letter, should be angle C. Which means that O is going to be 68 later on if we need to find that. The scale factor from MNO to ABC. MNO is the small one to ABC is the big one, so we're going this way. So let's see if we can match up anything to help us there. Let's color code a little bit here. MNO, MN, first two letters should go with AB, first two letters. So there's two sides that go together. So if I do 27 over 18, new over old, that should be 3 over 2. All right, now these ones have equal signs, so we need to actually say what number it is. So the measure of angle ABC, that was 52. Angle A should match angle M. We actually don't know those, but we can do the triangle sum theorem, right? 52 and 68 gives me 120. 180 minus 120 is 60. So angle A, angle M should both be 60. And then X and Y. Well, where's my X? My X is on NO. NO should be BC. Okay, so let's do 5x plus 1 over 24 is equal to 18 over 27. When we cross multiply here, we're going to get 27 times 5x plus 1 is equal to 18 times 24, which is 432. If I distribute here, 27 times 5 is 135, plus 27 is equal to 432. So 135x should be equal to 432 minus 27, which is 405. And then we divide by the 135. And we get 3 for x. Then for our y is hanging out here. That's the 2y. So let's do 14 over 2y is equal to 18 over 27. 2y times 18 is 36y. 14 times 27 is 378. 14 over 2y equals 18 over 27, yeah. So 18 times 2y is 36y, 14 times 27 was 378. We divide that by 36, and we get 10.5 for y. Okay, that is a wrap there. This one just wants us to solve for x and y if they're similar. Okay, so we saw a picture similar to this before. The 3x minus 1 here on side AC should match with EC. So let's do 3x minus 1 is equal to, I'm sorry, not equal to, is over 4x minus 4. Set that equal to my numbers here with A, B, and DE. So 28 over 35. We'll cross multiply 35 times 3x minus 1 is equal to 28 times 4x minus 4. 35 times 3 is going to be 105. So 105x minus 35 is equal to 28 times 4. 112x minus 28 times 4 is 112. If I subtract the 105x, I get 7x. And then adding the 112 over, it's going to give me 77. So dividing gives me x to be 11. Now, as far as the y's go, let's do 4y over 4y plus 9 is equal to 28 over 35. When we cross multiply there, 4y times 35, 4 times 35 is 140. Oops, sorry. 140y. And then we're going to have the 28 times 4y plus 9. When I distribute over there, 28 times 4 is 112. plus 28 times 9 is 252. Subtracting the 112 gives me 28. Y is equal to 252. And dividing is going to give me 9. All right, so x is 11, y is 9. Hopefully that went well for y'all. And that is going to wrap up our video here.